Betelgeuse, also known as Betelgeuse, is a red giant star. If you put it where the Sun is, it would extend out to the orbit of Jupiter. It is enormous, very unstable, and about to explode. They are among the biggest explosions of radio energy in the entire universe, generating more energy than a billion suns. Betelgeuse or Betelgeuse is a red giant star. If you put it where the Sun is, it would extend out to the orbit of Jupiter. It is enormous, very unstable, and about to explode. When we think of stars, we probably imagine tiny, shiny items in the night sky. At least this is how we see them from down here on the planet. But stars are something else entirely. In fact, one of the biggest stars, Betelgeuse, happens to be much larger than our Sun. For years, this star has baffled scientists, but recently, something more unsettling has been happening with Betelgeuse, making scientists and other well-informed folks very, very concerned. Join us in this video as we explore the terrific news about Betelgeuse, its impending destruction as expected by the James Webb Space Telescope, and how this new development will affect our galaxy and our lives right here on the planet. As explained by physicist Michio Kaku, Betelgeuse is a cosmic wonder, a large star that has intrigued cosmologists for so long. A Greek astronomer named Ptolemy was the first to discover it. This star is so huge that it can be seen in the night sky from Earth, particularly during winter. If you're into constellations, you've probably seen or heard of this star. It is the reddish-orange star that marks the upper left shoulder of the Orion constellation. So you see, this star is ancient and so far one of the brightest stars in the night sky. But one thing about Betelgeuse's brightness is that it doesn't stay constant. Instead, it fluctuates. This fluctuation is one of the unique properties of the star, but it isn't the only one. Let's look at some of Betelgeuse's specific properties. Most of the stars you see in the night sky are actually far from Earth. The nearest star is 4.2 light-years away from Earth. If you don't understand how the term light-years explains distance, picture it this way. Consider moving at the speed of light for a whole year. It's been proven that light can cover a distance of 186,000 miles per second. Therefore, the distance light can cover in a year is equal to 1 light-year. If you do the math, you'll have billions of miles. So when we say the closest star is 4.2 light-years away, it means it is billions of miles away from Earth. But guess what? Some stars are even farther, and Betelgeuse is one of them. Betelgeuse is located approximately 600 light-years away from Earth. So if you were to travel to it at the speed of light, it would still take 600 years. We can't move that fast. Not even our fastest spacecraft can. But this star can still shine so brightly in our sky. If you're wondering how Betelgeuse can be so bright despite its distance, that's because of its other qualities like size and brightness. Betelgeuse is about 500 times larger than our Sun. Its radius is believed to be about 1,000 times that of the Sun. It's so big that it appears as a disk in space when using sophisticated telescopes, while other stars appear as little points of light. This appearance is suspected to be an effect of the reactions at the outer layers of its atmosphere. In terms of mass, Betelgeuse measures about 12 to 19 solar masses. A solar mass is the standard unit of mass used by astronomers. One solar mass is equal to \2 times 10 carat 30 kg. Scientists cannot determine the exact mass of Betelgeuse because there are no other planetary bodies orbiting around it to compare with, and of course we can't measure it directly from here on the planet. But it's proven that this star is at least 12 times heavier than our Sun. The brightness of Betelgeuse ranges from magnitude +0 to +1.6. In more familiar terms, Betelgeuse is 16,000 times brighter than our Sun. No wonder it was nicknamed a red giant. However, the brightness of Betelgeuse doesn't stay constant. It fluctuates. This fluctuation is due to its pulsations. In other words, Betelgeuse expands and contracts. When it expands, it gets brighter, but when it contracts, it dims. This process can last for 10 to 100 days or even more. One unique property of Betelgeuse is that its surface is covered in dark magnetic spots. The magnetic field in these regions is far stronger than at the normal surface. But the downside is that these strong magnetic spots inhibit the flow of hot gas to the star's outer surface, making the star cooler in these regions. The fact that Betelgeuse has lots of these spots compared to our Sun explains why it is cooler than our Sun despite its size and brightness. The Sun also has its own dark magnetic spots, but those on Betelgeuse are much larger and very numerous. To give you an idea, the spots on Betelgeuse can be twice as large as Earth. Betelgeuse also boasts a magnetic field that is 1,000 times stronger than that of the Sun. This field is why, when viewed through a telescope, the gases on the surface of Betelgeuse appear to be in loops or arcs. Betelgeuse has a surface temperature of about 3,500 K. This low temperature contributes to the low energy emitted by the star and its dim red color. Betelgeuse is a red star, but it wasn't always red. It was yellowish about 2 million years ago, just like our Sun. Over the years, the color started changing to orange-red, and then about 2,000 years ago, it slowly started becoming the red star we know today. This fact has made scientists believe that the star is aging. Betelgeuse emits as much as 7,500 times more energy than the Sun. It would have been a fierce rival to Earth's Sun if it weren't so far away. In its prime, the fact that Betelgeuse, which is 600 light-years away, can still be seen and identified with the naked eye at night is quite remarkable. Our Sun is only 8.3 light-minutes away from Earth. That's why it's so powerful. If Betelgeuse were just slightly closer, we would also be able to see it during the daytime. But if it were to replace the Sun, it would swallow up or displace the Earth and the other 4 planets near it because of its enormous size. Furthermore, even if it could match it, it emits more radiation than our Sun. Betelgeuse, also known as Betelgeuse, is a supergiant star located in the constellation Orion, approximately 600 light-years away from Earth. Its immense size is one of its most striking features. It is about 500 times larger than our Sun in terms of radius and could easily encompass the orbit of Jupiter if placed at the center of our solar system. This colossal size allows Betelgeuse to appear as a distinct disk rather than a point of light when observed through powerful telescopes. Unlike most other stars, despite its enormous size, Betelgeuse is not the most massive star. It ranges in mass from about 12 to 19 times that of the Sun. This variability in mass estimation is due to the challenges in accurately measuring the mass of stars that lack a companion star or other objects to provide gravitational reference points. Nevertheless, even at its lower estimated mass, Betelgeuse remains a significant stellar object. The brightness of Betelgeuse is another noteworthy characteristic. It varies regularly over time, with its brightness ranging from magnitude 0 to plus 1.6. For comparison, a magnitude 0 star is about 2.5 times brighter than a magnitude plus 1 star. At its brightest, Betelgeuse can be 16,000 times brighter than our Sun. This variability is attributed to its pulsations, periodic expansions and contractions caused by internal processes within the star. When Betelgeuse expands, it becomes brighter. When it contracts, it dims. These pulsations can last for days to months, contributing to its dynamic appearance in the night sky. Betelgeuse's surface temperature is relatively low for such a large star, measuring around 3,500 Kelvin. This gives it a distinct reddish-orange hue, characteristic of red giant stars nearing the end of their life cycle. Like other red giants, Betelgeuse is in the late stages of stellar evolution. It has exhausted the hydrogen fuel in its core and begun fusing heavier elements. This fusion process generates energy and causes the star to expand outward. The star's atmosphere is rich in complex physical phenomena. It exhibits dark magnetic spots on its surface, which are significantly larger and more numerous than those found on our Sun. These spots are regions of intense magnetic activity that inhibit the flow of hot gases from deeper within the star to its surface, contributing to cooler spots on the star's surface. Betelgeuse's history and cultural significance also make it a prominent celestial object. Known since ancient times, Betelgeuse has been observed and documented by various civilizations. Its visibility in the night sky, particularly during winter in the northern hemisphere, has made it a prominent feature in constellations and mythology. In recent years, Betelgeuse has garnered increased scientific attention due to its dimming episodes, which began around late 2019 and continued into early 2021. During these periods, the star's brightness dropped to unprecedented levels, sparking speculation among astronomers about its imminent fate. Betelgeuse is expected to end its life in a supernova explosion, which will have profound effects on its surrounding environment. Such an event will enrich the interstellar medium with heavy elements and potentially contribute to the formation of new stars and planetary systems. The study of Betelgeuse is crucial for understanding the life cycles of massive stars and the broader implications for galactic evolution. Observing Betelgeuse presents challenges due to its immense size and brightness. Advanced observational techniques, including interferometry and space-based telescopes like the Hubble and James Webb Space Telescopes, are employed to study the star. These tools allow scientists to gather detailed data about Betelgeuse's physical properties and behaviors. The James Webb Space Telescope, in particular, is expected to provide new insights into Betelgeuse's atmospheric dynamics and the processes leading to its eventual supernova explosion. Future research will continue to explore these phenomena and refine our understanding of stellar evolution. The study of Betelgeuse has broader implications for our understanding of the universe. By examining such massive and distant stars, scientists can gain insights into fundamental processes governing stellar behavior and the dynamics of galaxies. Betelgeuse serves as a natural laboratory for studying extreme stellar phenomena and contributes to our overall knowledge of cosmic evolution. This research not only enhances our understanding of individual stars, but also informs our knowledge of the broader mechanisms shaping the universe. Betelgeuse, a prominent red supergiant, is often used as a key reference in studies of stellar evolution. Its massive size and brightness make it an ideal candidate for examining the final stages of stellar life cycles. Despite its grandeur, Betelgeuse's life is finite, and it is believed to be in the latter part of its evolutionary path as a red supergiant. Betelgeuse has already transitioned from the main sequence phase, where it primarily burned hydrogen, to a stage where it now fuses heavier elements in its core, such as helium and carbon. One of the intriguing aspects of Betelgeuse's evolution is its mass loss. Red supergiants, including Betelgeuse, shed significant amounts of their outer layers through powerful stellar winds. These winds can expel up to a few solar masses of material into space over the course of the star's lifetime. This process enriches the interstellar medium with heavy elements, which eventually contribute to the formation of new stars and planetary systems. This stellar wind is responsible for creating a surrounding shell of gas and dust observable with advanced telescopes, further informing our understanding of stellar mass loss and its impacts on galactic chemistry. Betelgeuse also plays a role in testing theoretical models of stellar behavior. Scientists use its observed properties to validate and refine models that predict how stars of various masses evolve. These models are essential for understanding not just Betelgeuse, but other massive stars across the universe. For instance, the behavior of Betelgeuse during its pulsation cycles can provide insights into the complex processes driving stellar oscillations and their effects on a star's outer layers. The study of Betelgeuse is part of a broader effort to understand the life cycle of stars and their ultimate fate, supernovae. The end result of Betelgeuse's evolutionary path are critical events in the universe, leading to the creation of neutron stars or black holes. These explosions also play a significant role in galactic dynamics, influencing the distribution of elements throughout the galaxy and impacting the formation of subsequent stellar generations. As we continue to explore Betelgeuse and similar stars, we gain valuable knowledge about the universe's ongoing processes of creation and destruction. Betelgeuse's prominence in the night sky and its distinctive characteristics make it an essential subject for both amateur and professional astronomers. The star's variability, a result of its pulsations, provides valuable data for understanding the mechanisms behind stellar brightness changes. Researchers closely monitor these fluctuations to gain insights into the complex interactions occurring within such massive stars. The star's regular brightness variations also serve as a natural laboratory for studying the behavior of red supergiants, which are otherwise difficult to observe in detail due to their rarity. Another intriguing aspect of Betelgeuse is its impact on the surrounding interstellar medium. As it sheds material through strong stellar winds, it contributes to the creation of what are known as circumstellar shells. These shells can become dense enough to form complex structures and sometimes even new stars. The interaction of Betelgeuse's winds with the surrounding interstellar gas can trigger shock waves that compress the gas and dust, potentially initiating star formation in nearby regions. This process highlights the interconnected nature of cosmic phenomena, where the life and death of one star can influence the birth of others. Furthermore, Betelgeuse's potential as a supernova candidate holds significant interest for astrophysics. The star's impending explosion will provide a rare opportunity to study a supernova event in detail. Such an explosion is expected to be visible from Earth even during daylight, offering a unique chance for observations. The supernova will not only illuminate the vast energy released during such events, but will also contribute crucial data on the mechanisms driving these cataclysmic explosions.